because what we're going to cover now, and actually, Alistair, we can hit the button for that, is a section which I absolutely love. I'm going to talk to you about quantum physics, but not like quantum physics was at school. Yeah, not like physics was at school. Different than that. And quantum physics, the reason I like quantum physics is because literally quantum physics for me is where magic meets science. And as many of you know, on a Thursday night, I do a Facebook Live at 7 p.m. But obviously, I'll be here with you. So I thought what I'll do is I'll film it, where magic meets science, and actually broadcast that as the Facebook Live on Thursday. Yeah, but we can't see you. It's okay. It's going over your heads. Let's just hope the material doesn't. So I'm going to give you a whole set of ideas from quantum physics, and what I've experienced in the past when I've been teaching this is it works best if you hold your questions right until the end. You know, when I ask for questions, because quite often questions come up, but the next piece I'm going to teach will actually answer it. So it actually works best if you kind of like hold your questions, and if there's any remaining questions at the end, then we'll have plenty of time to take them. So we'll go into history to the 1800s, and scientists believed that they knew everything there was to know about the workings of the universe. There wasn't anything else to discover, which I find quite fascinating today, because apparently one of the statistics is that 95% of the information on the planet today didn't exist before 1963, which was actually the year I was born, so obviously that's my fault as well. And but in the 1800s, scientists believed that they knew everything that there was to know about the workings of the universe, except for two things: light and optics. So nothing major if you think about it. And the reason that they couldn't fully understand light was, and you might have actually done this experiment at school. It's called the double slit experiment, where you took two pieces of card, one with a single slit in it, one with two slits in it, and then you put a screen here, and you took a light source here, and what happens if you remembered was that you would think that you would get like a stripe or a slit of light there and one there, but you don't get that. What you actually get is lines of light and dark across the entire screen, which basically proves that light is a wave phenomena, in that what happens is you get light waves coming through this slit, and then you get two sets of waves of light coming through this slit, and where they cross each other, they interfere and create bands of light and dark. Just like if you were to throw two pebbles into a pond, you get ripples of waves coming out from the pebbles. Where they met, they would interfere, and they create an interference pattern. So therefore, what we've got as far as this is concerned is proof that light is a wave. So then somebody decided that what they were going to do was they wanted to take a photograph of this wave phenomena here, just for posterity. So what they did was they put a photographic plate in place of the screen, and they took a photograph of it. But then you see, a photographic plate, just like the photographic sensor in your phone or your digital camera these days, only work if light is a particle. So a particle of light, a photon, hitting a photosensitive chemical will change its nature and have it go from white to black. or a photon hitting one of the cells in the sensor in your digital camera will cause it to release an electrical signal. So what we've got is we've taken an image of a phenomena that proves that light is a wave using something that requires light as a particle to operate. So one of the common things we find in quantum physics is that quantum physicists create a new kind of like phenomena, if you like, to explain what we're getting. And so what they created was the wave-particle duality of light, in that light acts like a wave when you're observing it as a wave, and it acts like a particle when we're observing it as a particle. Yeah. So that then starts to bring in the whole idea of the observer effect, because the way that we actually observe light changes the very nature of the light. So they then did another experiment with the same two pieces of card and the screen at the back. And what they sent through this was a single particle of light. Just one particle, one photon. And what they found was that when both of these slits were open, again, light acted as a wave, and you got these bands of light and dark, even though you only released one photon. But if you closed this slit here, the one at the bottom, so there's only one slit, the photon of light did that. So when there was only one slit open, light acted like a particle. When both slits were open, light acted like a wave. Again, we've got this wave-particle duality of light. But then the question is, how does the light going through that slit there know whether that slit there is open or not? Interesting one. Now here's the other interesting thing that they did. They replaced this single photon source of light with a telescope. And they pointed it at a distant star. Let's say they pointed it at a star that was around about 10 light years away. So the light from the star took 10 years to get to Earth. And you put it through here. Now, if you block that slit there, the light acts like it's a particle. If you open that slit there, the light acts like a wave. But the light left the star 10 years ago. So by the very action of opening and closing this here, are we changing history? Yeah. Now, another quantum physicist by the name of Schrödinger postulated a particular experiment. And by the way, before I actually tell you what this experiment was, this was just a thought experiment. No animals were actually harmed during this experiment. Because what he postulated was, he said, if you take a box, and in this box we put a cat. I'm actually going to write the word cat on that so you know what it's supposed to be. Yeah. This is why I'm an NLP master trainer rather than an artist. Okay, that's a cat. And we put into this box some poison, deadly poison, which had got a 50-50 chance of being released. If it's released, the cat will die. If it's not released, the cat will live. Okay? And then you close the box. At that point in time, for all of us in the room, the cat is in a very unusual state, because we don't know whether it's alive or dead. All we've got is a probability of the two. So the cat is half alive, half dead, and will remain that way until somebody opens the box. Yeah. So let's say that curiosity gets the better of me. I open the box, have a look inside, close the box. I look inside and the cat's alive, but I don't tell any of you. So now I have a universe with a box with a live cat in it, and you have a universe with a box with a cat which is 50% alive and 50% dead in it. Yeah. Let's then say that Jonathan's curiosity gets the better of him, and Jonathan looks in the box, and since I looked, the poison's been released, and the cat's dead. He closes the box, but he doesn't tell any of us. So now I've got a universe with a live cat in the box. Jonathan has a universe with a dead cat in the box. And everybody else in the room has a universe with a cat that's 50% alive and 50% dead. So the cat can't be alive or dead in any certainty until someone actually observes it. So therefore, me observing the cat alive made the cat alive. Jonathan looking at the cat and it being dead killed the cat. So from a cause and effect point of view, Jonathan killed the cat. But did he? Or was it just Jonathan's curiosity that killed the cat? Is that where the saying comes from? Curiosity killed the cat. Yeah. So that's the observer effect, the power of the observer effect. And Schrödinger actually said that if you are not totally appalled by the repercussions of the observer effect, you don't understand it. Because literally, what you've got is until we actually observe something, all we've got is probability. It's a little bit like King Midas. You know, King Midas walked along, and everything he touched and everything he looked at turned to gold. So he thought the entire universe was made of gold, but it wasn't until he arrived. It's a little bit like, you know, our Queen. She thinks the universe, every single place in the world smells of paint. Because just before she arrived, somebody's there painting the place. It didn't smell of paint before she arrived. So does she make the entire world in her reality smell of paint? Yes, she does. Yeah. So that's the observer effect. And we're kind of like, you know, we're walking around, we're walking down the street, and behind us is just pure, infinite possibility, infinite probability. Everything in front of us we observe into being. But if we attempt to catch it out and go, okay, what's actually behind me? As soon as we turn around and look, we observe it into being. Which is exactly the same thing as I was talking to you about yesterday, which is like, where does your body go when you fall asleep at night? Because you're not there to observe it, it disappears. And then reappears the next morning when you wake up and observe it into being. So that's the observer effect in quantum physics. Now, another experiment that they did is, and this is, I'm going to simplify the actual experiment just for the purposes here. Let's say that we take an electronic particle, and we fire at the electron another high energy electron. These aren't actually the kind of particles they were, I'm just simplifying it. And you fire this thing at this particle here. What they found was that it split into two particles. Yeah. Now, when they measured the particle, whenever you measure something, whenever you observe something, you change its nature. So when they measured this particle here, it changed direction. So all we can say is, once we observed this particle, once we measured it, it changed direction. We don't know what direction it was coming from before we observed it. All we have is a number of probabilities and a number of possibilities. But what they found was that when they measured this one here, and it changed direction in a particular way, that one changed direction in exactly the same way at exactly the same time. As in t equals 0. Now this upset somebody whose name you'll definitely recognize from the world of quantum physics, Einstein. Because basically what we've got here, they said, well, obviously this electronic particle over here is communicating with this particle over here instantaneously. And to do that, that must have a communications method which is moving at faster than the speed of light, because it's instantaneous. Einstein's entire theory of relativity was based on the fact that nothing went faster than the speed of light. So that experiment appeared at first to blow out Einstein's theory of relativity, his life's work. You would be a bit grumpy if that happened. But then there was a different postulation as to what was going on. What if, they said, there was some level of reality where those two particles actually weren't separate. They were the same particle. And what we're looking at is two different views on the same thing. And they said, well, if this level of reality existed, then we'll call it the M field or the morphogenic field. A level of reality where everything is one, pure level of information. So to put it in a different way, imagine if what we've got here is we've got a room, and in this room there's a fish tank. It's a fish, by the way, in case you're wondering. And we've got a camera looking that way to the tank. And there's also a camera looking this way into the tank, which obviously I can't do on the flip chart because I've only got a two-dimensional flip chart, not a three-dimensional one. And in another room, we're looking at two TV screens, which appear to be showing two different fish. But then we start to notice there seems to be some relationship between the way this fish moves and this fish moves. So it appears the two fish are communicating with each other, but in actual fact in the other room, it's the same fish. And this is a whole idea of the morphogenic field. You might have heard of the idea of the 100th monkey syndrome. So the story goes, there were some anthropologists researching monkeys on a very remote island. And they would feed the monkeys and then give them sweet potatoes. They'd dump the sweet potatoes on the beach and the monkeys would eat them. But of course the sweet potatoes were covered in sand. So one of the scientists actually took one of the monkeys and actually taught the monkey to wash the sweet potato in the sea. So it got no sand on it, but now it was salty, sweet and salty. Yeah. So this monkey started teaching the other monkeys to do the same thing. And on a completely separate project, on a separate remote island, suddenly, one day, out of the blue, all of the monkeys started washing their sweet potatoes in the sea before they ate them. And so the idea of the morphogenic field is that when a certain percentage of the population adopt a new behavior or a new way of thinking, suddenly, instantaneously, it goes throughout the entire population. So, there's some another research study done with bees. Now, if you were to take a single bee, I don't think we'd necessarily call them particularly intelligent. I mean, because they can't even work out which window's open. When you've got a bee in there and you open the window so they can get out, they keep banging at the piece of glass, even though all they know what to do is go up a little bit and out. They can't even work that out. But when you take a collection of bees, like a hive, for instance, they start to be able to do some things which are quite intelligent. So, for instance, the bees in a hive can control the temperature of the hive, inside the hive, to within 1/10 of a degree, which is significantly better than the air conditioning system in this hotel room. Yeah. How do they do that? Well, if the temperature in the hive starts to increase, some of the bees go out, they get water on their fur, they bring it back into the hive, and the other bees flap their wings to evaporate the water and takes the temperature down. If the temperature of the hive drops too far, some of the bees use their body to block up the holes in the hive, and the rest of the bees scurry around fast inside, and the temperature comes back up. Yeah. So these scientists, what they did was they found a beehive. That's a beehive, by the way. Yeah. And so there's this beehive here. The bees go out at the beginning of the day to go and get some pollen, all that kind of stuff. And the scientists put the beehive on the back of a truck, and they drove it in a particular direction, a distance of X miles. When the bees came back at the end of the day, the hive was gone. They flew around and found it. When they went out to work to go and fetch the pollen the next morning, the scientists picked up the hive and drove it the distance in the same direction, a distance of 1.1x, 10th as far again. Bees came back, couldn't find the hive, flew around, found it. Next day, the same thing happened, but the scientists moved the hive this time a 10th as far again. So now they move it a distance of 1.1 squared x. The bees come back, can't find it, they fly around to find the hive. Next morning, the whole thing repeats itself. The bees go out to do their work, and the scientists pick up the hive, and they drive it in the same direction, a 10th as far again. So that's 1.1 cubed x. When they got there, the bees were waiting for them, and they were pissed. Yeah. So I don't know about you, but I don't know if I can work out 1.1 cubed in my head, but it appears that a collection of bees actually have the ability to do that. Also, ants do the same thing, If you've got a big ant's nest, the ant's nest is very, very organized, as long as the queen ant is alive. But if you take the queen ant out of the nest, put the queen ant on an aeroplane and fly it to Australia, the ant's nest will stay organized, even though the queen ant is on the other side of the planet. If you kill the queen ant in Australia, the nest in the UK immediately goes out of control. So how does the queen ant communicate with the nest in the UK from that distance instantaneously? These will all seem to be evidence of this thing called the morphogenic field. Now, the Maharishi Yogi organization decided to do some experimentations around this, because they thought if we can get a certain number of people all meditating at the same time, then could we shift the consciousness of the planet? So one experiment that they did, because they've got literally millions of people who've been taught transcendental meditation around the planet, to actually join in with this experiment. And there was a conflict in the Middle East at the time, and they wanted to see if we could get a whole bunch of transcendental meditators meditating all at the same time for one particular day, whether they could impact what was happening in the Gulf. And so they organized, in the Middle East, I don't know if it was the Gulf or not. And so they got all these meditators meditating on this particular day, and for no explained reason, there was a ceasefire that day. It wasn't planned, nothing like that, but no side fired anything on either side for a day. And when the day finished and all the meditators finished, all the firing started again. They did another experiment in New York City, a particular area of New York, in conjunction with the New York Police Department. They wondered if they got a certain number of people meditating in a particular area of New York City, whether they could affect the crime rate. And so they organized this thing. They got all of these meditators meditating in this particular area of New York City. And the police department actually confirmed that on that day, whilst all these meditators were meditating, the crime rate plummeted. And the next day, it went back up to normal. Now, there's only two possible explanations for that. One is all of these meditators are affecting the morphogenic field and the consciousness of all the criminals in that area of New York City, or all transcendental meditators are criminals and we're meditating on that day rather than doing acts of crime. There's only two possibilities for that particular thing to happen. Yeah. So, interestingly, then, if we take that to another level, you remember, like in biology, but you first start studying single-celled organisms like amoeba and protozoa and all those kind of things that you can look at through your microscope. Yeah. Well, every single cell in your body exists in nature as a single-celled organism, and it survives totally all by itself as a single-celled organism. Every single cell in your body exists in nature as a single-celled organism. Now, when you stepped up from single-celled organisms and started looking at multi-celled organisms, the first thing that you think you study is hydras. Can you remember those? Like these green tube things with tentacles, and they threw spores out and all that kind of stuff to reproduce. Well, there's one particular organism that spends most of its life as a green slime of single-celled organisms. And they all survive just purely by themselves, reproducing by themselves. Then at a particular point in their life cycle, this green slime collects itself up and creates what looks like a hydra. And certain cells that in this organism start to specialize in their function. Some in the tube part of it, some in the tentacles, and some of them actually produce spores, which they send the spores out to reproduce. Once the spores have been sent out, then what happens is this hydra-like organism disintegrates and becomes a slime of single-celled organisms again. Could that be what's happening with our bodies? Since every single cell in your body exists as a single-celled organism, it doesn't need the other cells to live, to exist. But as at a certain point in time, all of these cells get together to create the morphogenic field called you. And then after it's done its purpose of being created in the morphogenic field called you, it disintegrates back into being a slime of single-celled organisms. Because there is a morphogenic field of you. But when anybody gets together, they create a morphogenic field. So there's a morphogenic field for the NLP practitioner, master practitioner certification. There's a morphogenic field called the population of the UK. There's a morphogenic field called the population of the world. And when you look at the percentage and the postulation that when you get a certain percentage of a particular population all thinking the same way and behaving the same way, then everyone suddenly starts doing the same thing. The postulation is that percentage is the square root of 2. Now, if we were to again shift gears from observer effect, morphogenic fields, to the idea that the universe that we live in is a hologram. This is one of the postulations in quantum physics at this particular point in time, is that we live in a holographic universe. Yeah. And again, you know, and we are, if you like, a holographic. Oh, that's interesting. Where did that come from? A hologram fell out of the sky, just as I was talking about such things. There we go. How interesting is that? There we go. The effect of the morphogenic field. So again, we are a holographic projector. Our nervous system is a holographic projector. Again, which is why when you fall asleep, you switch the projector off. And everything that you're projecting out when you're awake disappears. But then we dream. Now, how many of you here have had a dream that's so vivid that you didn't realize it was a dream until you woke up? Right. So the neurological mechanism for creating dreams is exactly the same as the neurological mechanism for creating this. In fact, in all of the ancient teachings on the planet, they had that we live our life through two dreams. The dreams we have when we think we're asleep, and the dreams we have when we think we're awake. Now, for instance, I know for a fact that none of you can provide me with any tangible evidence that in a moment you're not going to wake up and find that you haven't come to the training yet. I mean, the only way that you would know that this was a dream training is that the dream trainer at the front of the room would be talking all kinds of weird shit. That's the only way that you would know that this is a dream. But, you know, we've got this culture now where we go, the dreams that we have when we think we're awake are the real ones, and the dreams that we have when we think we're asleep aren't the real one. But what if we got it the wrong way around? What if the dreams that we have when we're asleep are the real ones, and the dreams that we have when we think we're awake are the non-real ones? Because then, you see, this is what would happen. Tonight, as you go to bed, you would set your alarm for the time that you wanted to sleepen yourself up in the morning. You'd put your head on the pillow and you'd fall fast awake. And you'd dream. And then the alarm would go off and you'd just sleepen yourself up. And you'd dream. And you'd dream the dream all day whilst you're asleep. And then you set your alarm that night for the time you want to sleep yourself up in the morning. You put your head on the pillow and you fall fast awake. And you dream. So this is the idea of the fact that the universe is a hologram, and that our nervous system is a holographic projector. Yeah. Now, holograms are interesting because if we took a hologram of that glass, it would look and we projected it, it would look exactly like that glass. You could walk around it, you could look on the top of it, you could look underneath it. The only thing is, you'd be able to pass your hand through it. Yeah. Now, a holographic image is very different than a regular photograph. Firstly, if you were to look at the holographic plate, you wouldn't see a glass on it. What you'd see is circles of light and dark, because a holographic plate is an interference pattern. And the only way that you can actually see what the hologram is of is by shining a laser through it. Yeah. But the other thing with a hologram, which is different than a picture, is if we took a hologram of a glass of water and we split it in two. If it's a photograph, you get a photograph of the left side of the glass and a photograph of the right side of the glass. That's not what you get with a hologram. What you get is two holograms of the entire glass. If you then did it again, with both halves, you'd have 4 holograms of the glass. Then 8, then 16, then 32, then 64, 128, 256, 1024. See, there was a use to me learning how to count in binary. Yeah? And you'd have 1,000 tiny little holograms. But even with a hologram as tiny as that, or even one as tiny as that fell out of the sky, when I was talking about holograms, you would have a hologram of the entire glass. So the thing with holograms is that each of the parts contain the whole. Yeah? The whole image is in each part. The only thing that happens is as you break it into smaller and smaller pieces, the quality of the image degrades, but it's still the entire image. That would appear to be the way that our nervous system works. In that, where are you in your body right now? Well, the answer normally is, well, I'm everywhere. But nowhere. You remember that song? You're everywhere and nowhere, baby. That's where it's at. That's actually a song about holograms and quantum physics. You didn't realize that at the last dance wedding, but that's what it was. When you were there going, it's everywhere and nowhere, baby. That's where it's at. You were learning quantum physics. Yeah. But equally, if somebody sustains some damage to their nervous system, they don't lose like specific elements of their memories. They've still got all of their memories. What happens is the quality of their memories degrades. It's not like, last week is there. Last week appears to be everywhere. So it also appeared that the nervous system is holographic and it projects out the universe. Now, I think it was Carl Pribram, or it might be been Boehm, I can't remember, one of the quantum physicists, had got all this, and he goes like, okay, so if the universe is a hologram, what is it a hologram of? Because if we got this hologram here, we shine a laser through it, and it appears to be a glass, we know we've got a hologram of a glass. But if the universe is a hologram, what is it a hologram of? And he asked himself that question over and over and over again. And he only ever came up with the same answer, but he daren't tell anybody. Because he was so worried what people would think when he told them the answer to that question that he got. And he finally did. He said, if the universe is a hologram, what is it a hologram of? The only answer he ever came up with is the universe is a hologram of me. So in actual fact now, what we've got in quantum physics is we've got cause and effect, the observer effect, but also we have perception as projection, in that the universe is a hologram of me. Like in the Taoist tradition, as in the microcosm, so in the macrocosm. So if we look at, and by the way, also, the storage capacity of a hologram is huge. In a holographic plate, the size of a postage stamp, that big, has the storage capacity to hold the entirety of 50 Bibles in that amount of space. Could that also help to explain the huge storage capacity of this thing that's relatively small, the human nervous system? Because, even if we're looking at the old figure of receiving 2 million bits per second of information all of our life, as I said, my phone, 64 gigabyte phone, would be full by the end of the day. The latest research would suggest that we're receiving information at the rate of 12 million bits per second, rather than 2. But that's all faithfully stored within our nervous system, in this relatively small area of space. Technology still hasn't got to the point where they can store that much information in such a small area of space, but also where all of the information is in every part of that nervous system. It's the ultimate backup system. Your nervous system is the ultimate RAID storage system. Like, in actual fact, if as much as 90% of it went down, you would still have the entirety of the entire storage that's gone on in there. But if you looked at how do we create a hologram, and we've got our glass there, then what we do is we take a laser beam and we put that laser beam through what's called a beam splitter. So part of that laser beam actually goes through and part of it's reflected around the glass. And you take the light that's gone around the glass, the pure laser, and then the light that's gone through the glass and has been refracted and reflected, and you combine them two here, which creates an interference pattern. And you take a photograph of that on a photographic plate, and that's how you create a hologram. To be able to project the hologram, we need to shine the same kind of laser through it, and through the other side of the hologram will appear the hologram of the glass. Now, these kind of holograms aren't the kind of holograms that we're talking about on your credit card. Yeah, not that kind of hologram. If you want to see real holograms, the Museum of the Moving Image on the South Bank every now and again have a hologram exhibition. You can actually go and see real holograms. Yeah. Now, if that's how we create a hologram, another idea in quantum physics is not only that the universe is a hologram, but also the existence of parallel universes. Yeah. And the idea being there is a universe with a you in it that is doing everything you could possibly be doing right now, actually doing that. This is just the one that you're choosing to observe at this particular point in time. But there is a parallel universe with a you in it that's doing every other possible thing that you could possibly be doing at this particular point in time in a range of probabilities. So if we were to take our timeline, then what we have is we have, if you like, an infinite possible number of probable pasts. There's a universe with everything that possibly could have happened in your past actually happening. And what that creates is a probability wave, because some of those universes cancel each other out because they're opposites. But then we've got a probability wave as these different universes actually collide. We have a probability wave coming from the past. But equally, as we're here right now, there is an infinite number of possible probable futures that could happen in the next minute, the next day, the next month, the next year. Some of those, again, will cancel each other out because they're equal and opposite. But what we've got is a probability wave coming from the future. These two probability waves collide at this space in time called now. Now, in actual fact, the only thing that you can experience is now. Yeah? We can't experience the past. Yeah, you can bring a memory up from the past, but you haven't actually gone into the past. What you're doing is you're bringing up a memory of the past now and experiencing it now. Equally, we could think about what we're going to do tomorrow, but you're not at tomorrow. You are experiencing tomorrow, one possible tomorrow, now. So the only thing we can experience is now, this thing here. And that is created by the interference pattern of two probability waves, one coming from the past and one coming from the future. So therefore, how do we change our experience of now? Well, we could change the probability wave coming from the past by releasing negative emotions and by deleting limiting decisions. Or we could change the probability wave coming from the future by putting congruent goals out in our future timeline. Or we could do both. We could release negative emotions, delete limiting decisions from the past, changing the probability wave from the past. We can change the probability wave coming from the future by putting congruent goals out in the future. And that changes our experience of now. Because your entire life is a series of nows. We can't change the past, we can't change the future, the only thing we can do is change now. Could that be how things like NLP, timeline therapy, hypnosis actually work and enable somebody to change their reality of now from a quantum physics point of view? I think that's probably been over half an hour for our Facebook Live people. So thanks for joining us, and we'll see you again next week.